Now, chapter number 7, system of particle and the rotational motion is there, and the topics which you want to discuss here, that is called the rolling motion, along with its basic statics is there, and kinetic energy of an rolling body in the rolling motion, and the velocity attained by the rolling body at the bottom of inclined plane. Okay. So, how can we discuss the concept of the rolling? So, generally, the rolling motion is a motion in which the body is making the translation, pure translation motion, as well as the pure rotational motion. Okay, and without the slipping is there. So, this motion is called the rolling motion is there. Okay. Now to understand the statics of this rolling motion, we are just imagining the two types of the motion individually, and then we will combine them. So how can we discuss the velocity of the different particle? Those are available on the particular given body, and this one given body is called the disk is there. Okay. So what actually I am is imagining, this one is a disk is there which making the pure translation is there. So whenever it makes the pure translation is there, so all the particle having the velocity which is equivalent to the velocity of the center of mass is there. Now all the particle are making the pure translation is there. So the particle which is at the A is having the velocity of center of mass is there. Same how the velocity the particle which is at the B having the velocity, that is called the velocity of the center of mass is there. Same how the particle which is at the bottom, that is called the C is there, which although having the same velocity, that is called the velocity of the center of mass. Now this is the statics we have of the pure translation motion. Now the body is making the rotation, making the pure rotation is there. So the particle which is at the point A is there for its velocity which is given by the tangent, and we know that the body is making the pure rotation with the omega angular velocity. So the linear velocity of the particle can be stated that v is equal to omega r is there. Now same how the particle as at the B having the tangential velocity, that is v is equal to omega r. Now this is for the particle C, and this is that is also called the, that is v is equal to omega r, and v is equal to omega r, which is for the particle could be here. Okay, now we are just mixing these two motions. So how can we discuss the statics? So I am just imagining the combination that is called the rolling motion. So I am just imagining this one motion. So the particle is at the A which having the two types of the velocity as per the combination of the pure translation and rotation is there. In the pure translation, the particle at the A is having the velocity that is called the velocity of center of mass, and the one of the another velocity that is called the v is equal to omega r. So the v total is the sum of the velocity of center of mass plus omega r is there. Okay, so this one is a justification we have of this statics. Now same how I am just imagining the particle at the B, it having the velocity along the x-axis, that is called the translation velocity, that is called the velocity of center of mass, and the velocity which is given by the tangent, that is called the v is equal to omega r is there. Okay, same how we want to calculate the resultant velocity. So there is a basic rule of the vector is there, that is called the parallelogram law is there. So we can find out the theta is the 90 degree, and v resultant can be find out here. Now the velocity which is for a particle which is at the C is there. Here I am just imagining this one point here. Here we have the two velocities, those are in a opposite direction to each other. Now here we have the v is equal to omega r in this direction. Okay, and the velocity of the center of mass along this one direction. These two velocities are equal and opposite to each other. So same how the particle, the velocity of the particle at the C, that is equal to the 0 is there. Okay, so this is the one of the important statics regarding to the rolling motion is there. Okay. So I have mentioned one of the basic fundamentals here. At the point A we have the total velocity, that is VCM plus omega r. At the B we have the velocity by the mean of the resultant if the two velocities are acting at a perpendicular distance to each other. So the resultant can be square as VCM square plus omega square r square, and at the C we have the velocity v is equal to 0 because the two velocities are in a opposite direction to each other. Okay, so this is the one of the basic statics we have. Now we want to discuss the kinetic energy of rolling body in the rolling motion. So here I have assumed the one of the basic situation is there, the body is making the rolling on a over on an inclined plane. So it's a total kinetic energy that K total is the sum of the Ke due to the translation is there plus Ke due to the rotational part is there. Okay, so here we can assume the formula of the K total in the part of the K translation, that is called the m velocity of center of mass square by 2 plus kinetic energy of the rotation motion, that half I omega square is there. Okay, so this is the one of the general equation we have. Now we want to put the basic changes here. Now v velocity of the center of mass is the called that is v is equal to omega r is there, so we can make the substitution of the omega in the part of the velocity of center of mass is to be divided by r is there. Okay, now here we have the moment of inertia of a body about the moment of the radius of the gyration, that is called the mi is equal to mk square is there. So this is the equation number 2 we have. Now we are just putting the equation number 2 in the equation number 1. So the total kinetic energy that is called the m velocity of center of mass square by 2 plus I is equal to mk square, and the omega square is equal to vcm square is to be divided by 2r square is there. Now I am just making the k total is the velocity of center of mass square by 2 with the bracket of 1 plus of k square upon r square is there. So this is the simplest total kinetic energy of a body which making the rolling on a down inclined plane is there. Okay, same how we can also make the discussion about the velocity. For it we are just making the case is there. Now here we have to be discuss the topic velocity of the v attained by a rolling body at the bottom of an inclined plane of an inclined plane. So we are just imagining one of the basic consideration is there. Here we have the inclined plane is there, same how this the point A is there, this the point B is there, and inclined plane having the angle theta with the horizontal is there, this the point C is there. Now we are just imagining one of the rigid body is there, and which having its radius that is called the R is there. Okay, this is the part of the radius we have, and it's making the rotation with the angular velocity, and we are just imagining the surface which having the negligible resistance is there. Okay, we are just finding the velocity through for it. So we are just imagining that law of conservation of energy for a body. Here I want to make the little bit correction is there, the friction is the necessary to make the rolling of the body is there. Okay, if it is making the slipping, so there is a no meaning of the rolling is there. Okay, so the friction is playing the important role for its rolling. Now here we have applied the basic rule that total energy at the A is equal to the total energy at the B for a rolling body. Now at the A we have the total energy in the part of the potential energy is there. So we are just writing the potential energy that is equal to the gain of the kinetic energy. Gain of kinetic energy at B, and definitely his body is making the translation as well as plus rotational motion is there, so it having the two types of the energy, and the mgh is there at the point A is there. So the two types of the kinetic energy are there, that kinetic energy translation is there, and the kinetic energy rotational is there. So I am just writing both the formulas are here for the consideration. Now the general equation which I have written here, this is the equation number 1 and this is the equation number 2 is there. So the kinetic energy translation is there, half mv square, and the half I omega square is the kinetic energy of the rotation is there. Okay. Now we have the I is equal to mk square is the moment of inertia about the radius of gyration, along with v is equal to omega r is there. V is equal to omega r is there. So we can make the simply substitution, omega can be stated as a v by r is there. This is the equation number 3 have. Now we can make the consideration of the mgh is there, half mv square of mv square plus the concern of the mk square is there, uh, into omega square is the v square upon 2r square is there. Okay, so whenever we are just making the separation of the v, so it comes in the part of that mgh, as I am just making the changes in this equation, 1 plus k square upon r square is there. Okay, so whenever I am just making the separation of that, v is there, v square is equal to 2 mgh is there, with the concern of the m with the 1 plus k square upon r square is there. Okay, m to m cancel, so I am just making the under root of that part, so it comes about that v is equal to under root 2gh is to be divided by 1 plus k square upon r square is there. Okay, so this is the part of the velocity which is attained by a rolling body at the down inclined plane. Okay, here we have the g is the acceleration due to gravity, h is the height of an inclined plane, and the k is the radius of the gyration from the axis of the rotation, and r is the radius of a rigid body is there. So this is the simplest formula. We have the velocity attained by a rolling body at the inclined plane. Okay, so down inclined plane. Okay, so this is the one of the basic formula we have. Now we want to discuss the other things also. So we will solve also the numericals are there.